Alright, welcome back. In this video we're going to look at another example of solving by substitution. This one's going to be a little bit of a harder example. First, let's review our steps in the substitution method. First, we want to solve one equation for a variable, so we pick one of the equations. Again, we usually look for an equation that one of the variables doesn't have a coefficient. That way we don't have to worry about division. We don't have to worry about fractions. In the example we're going to look at in a moment, we just kind of have to bite the bullet. And there's not going to be an easy variable to solve for. Second step is to take that result, plug it into the other equation for the variable. That will produce an equation that has only one variable. We solve that new equation. Once we get an answer for that, we plug the answer back in to find the other variable. So consider the following system of equations. 3x minus 2y equals 8. Negative 2x plus 7y equals negative 10. This time, every one of my variables has a coefficient. So when I solve the equation, I'm going to have to divide by that coefficient. I just have no way around it. So we're going to pick an equation and solve for the variable. So let's say we take the top equation. 3x minus 2y equals 8. And let's say we want to solve that equation for x. So to solve for x, we begin by bringing the 2y over to the other side. So we'd have 3x equals 8 plus 2y. Divide both sides by 3. We would have x equals 8 plus 2y all over 3. If you wanted to break that up as 8/3 plus 2y over 3, you could. I'm just going to leave it in this format. And then we're going to take that result and plug it into the other equation, the negative 2x plus 7y equals negative 10, the one we haven't used yet. Replace the x with that expression. And we get this rather ugly looking thing, negative 2 times 8 plus 2y over 3 plus 7y equals negative 10. We have this ugly equation with a fraction in it. So the first thing I would do here is say let's get rid of the fraction by multiplying the whole equation by that common denominator. Now when I do that, first I'd have 3 times that whole fraction, negative 2, 8 plus 2y over 3. The 3's will cancel out and we left with just negative 2 and 8 plus 2y. That's the hardest one to see there. It's going to distribute, so you're going to have the 3 times that stuff, and the 3 will cancel with the 3 in the bottom. Okay. Then the 3 times the 7y, that's easy. That's 21y. And the 3 times the negative 10, that's negative 30. Okay, so we now have an equation that doesn't have any ugly fractions in it. We want to solve that for the variable now. So we can begin by simplifying. Negative 2 times 8 plus 2y would be negative 16 minus 4y. And then plus 21y equals negative 30. Combine like terms, we have negative 4y and a 21y would be negative 16 plus 17y equals negative 30. So we want to solve for y, so we add 16 to both sides. We get 17y equals negative 30 plus 16 would be negative 14. Divide both sides by 17, we get y equals negative 14 over 17. Now step 4 is to take that result, plug it back into one of your equations. Now as I look at that equation that I solved over here, right, as I look at that equation, I say, oh, I got to put a fraction into that? No, I don't. Remember, I can actually pick any of the equations that I had relating x and y. And so because that one has that ugly fraction and I'm going to put a fraction into it, I don't want to do that. So here it's actually probably easier to pick one of those 2 starting equations. So I just say let's pick the first equation. 3x minus 2y equals 8. Replace the y with a negative 14/17. So we do that. So we have 3x minus 2 times a negative 14 over 17 equals 8. Simplifying, negative 2 times a negative 14 would be plus 28 over 17 equals 8. And again, I have an equation with fractions. And so I could, if I wanted to, subtract the 28/17 from both sides and then eventually divide by 3 to get x by itself, but that's kind of ugly. So what I'm going to do is get rid of the fractions by multiplying the whole equation by my common denominator, 17. That will distribute through. 17 times 3 would be 51x. 17 times 28/17 would be 28. And 17 times 8 would be 136. And so now I have an equation that has only one variable, and I go ahead now and I want to solve that equation. So I subtract 28 from both sides. Get 51x equals 108. Divide both sides by 51. Now 108 over 51 will reduce. You can actually cancel a 3 out of each one of those, out of 108 and out of 51. And so we get the answer 36 over 17. Okay, so a little bit harder. For this reason, we do have a second method for solving systems of equations, particularly when they're in the format like our two equations were here. And that's the topic of the next section. So these can be a pain in the butt, can be really meticulous and really involved. And we do have to be really careful as we're doing them. Lots of little places where we can fall into traps. But I did want you to see an example of, all gloves off, how messy these really can get. Okay, in the next video we're going to look at a couple of special cases with solving systems of equations. Until then.